Today we're going to talk about minerals. You see minerals around you all the time, and they're in the food that you eat and in your toothpaste and in many other items that you use on a daily basis. Now, we first start off with elements, and elements together make up minerals, and all of the different types of minerals make up rocks. Now, what is a mineral exactly? A mineral is a naturally formed, inorganic solid that has a definite crystalline structure. Now, what does that mean? First of all, naturally occurring or naturally formed means that it was made by a natural process with no help from humans. So, for instance, a diamond that would be made in a factory would not be considered a mineral. They also must be inorganic, which means they are not living and never were living. They can't be from plants or animals. So coal, as many of you know, is made from the remains of living things. That's why it's called a fossil fuel. So coal would never be considered a mineral. Now, minerals are always in the solid form. You don't find them as a liquid or a gas. And they have a definite crystalline structure, which means that within any mineral, the molecules would be repeating in these specific patterns called crystals. So, what is an element? We said that they were the things that make up these minerals, but what are they? Elements are pure substances that cannot be broken down into simpler substances by ordinary chemical means. An element is an element. It's a pure substance. There's nothing else mixed in it. You may have heard about the periodic table of elements. It is the big chart that organizes all the elements based on their properties. You can find this on page 794 in your book. I believe there is also a copy of it in your agenda. Now, if you remember in the beginning, we talked about minerals having a definite crystalline structure. And I said that the molecules would be repeating in these crystals. So if you look at this little picture, it shows you a chunk of gold broken down. And in the gold on the left, you can see how the minerals are arranged. Any chunk of gold that you pick up, it doesn't matter where it is. It could be in my backyard, it could be in your backyard, it could be in Miss Ogan's backyard. It doesn't matter. Any piece of gold is going to have that repeating pattern. It's going to have that crystal structure. There are two major groups of minerals that every mineral fits into. There's the silicates, and then next we'll talk about non-silicates. Silicates are minerals that contain a combination of silicon and oxygen. Some examples are seen here. We've got quartz, feldspar, and mica. Now here we have the non-silicates, and you can probably guess they're just the opposite of the silicates. These do not have a combination of silicon and oxygen. You can see some examples in the chart in this picture. There are hundreds of minerals on this earth. What do you think some ways are that we can use to tell them apart? There's going to be many different ways, some of which you can just look at the mineral, others in which you have to do a test. We're now going to talk about all the different ways that you can identify one mineral from another. I'm going to start by telling you about some special properties that not all minerals have. But some special minerals can be fluorescent, some are magnetic, and some have a taste. You may know of one that you put on your French fries. The most basic way to tell one mineral from another is just by looking at its color. But it's really not the most reliable way. You can't look at a blue mineral and say that it's sapphire, for instance, because a blue mineral could be hundreds of different types of minerals. So you would have to do some other tests after identifying the color. Luster is how a mineral reflects light. Every mineral has luster, it's just a different kind. So you wouldn't say, oh no, that mineral doesn't have any luster. You would say that it might have a dull luster. So we've got two major categories, metallic or non-metallic. And it sort of looks like in this picture that both of these might be metallic, especially the mineral on the left. Some other words that can be used to describe luster might be pearly, silky, opaque, glassy. Think about luster in like a piece of aluminum foil. That would probably be a metallic luster, and it would have lots of shine to it and reflect light, while a piece of talc, which is basically what baby powder is made out of, wouldn't have such a bright shiny luster. It would be more kind of like a pearly or silky luster. You should remember density when we talked about it not too long ago with our metrics unit. Density is how much matter is in a given amount of space. And if you recall, we said that the density of a specific mineral doesn't change. So when we talked about that story about Archimedes and trying to find out if the king's crown was gold, when he figured out how to calculate the volume and then therefore calculate density, he realized that the crown was actually not made of gold and the king was being fooled. Streak is the color of a mineral in powder form. So if you see here in the picture, we've got two different minerals. Looks like the one on the left is kind of like a blackish, and the one on the right is maybe a brownish red. When you take these minerals and scratch them against a streak plate, they'll leave behind a specific color of powder. The color of powder is not always the same as the color of the mineral itself. So this is a great tool in helping to identify minerals. Now what we've got here is two different ways that a mineral can break, and a mineral is going to have either one or the other. If you look on the left, those minerals in the picture break with cleavage, which means when they break, the crystal structure makes nice straight edges. If you look at like the fluorite and the halite, which is actually salt, and the calcite, those all broke with nice straight edges, but the one on the right has what we call fracture. It doesn't break with nice straight edges. It's kind of like jagged, uneven edges. The last property we're going to talk about is hardness. So when we talk about a mineral's hardness, it's not talking about like could it be broken with a hammer. It's talking about its resistance to being scratched. And to figure this out, you would use Mohs hardness scale. And certain everyday household objects have a hardness, like a fingernail, a copper penny, glass, a steel file, even a streak plate that we use for minerals. So you could test hardness of minerals by scratching them with these certain things and kind of seeing where they fit in on that Mohs hardness scale. Where can you find minerals? Basically everywhere. If you look at this list that we have here, you can find minerals in a dried up body of salt water. There would be tons of minerals there from the salt water that was there before it dried up. You could find minerals at the bottoms of lakes and seas. Minerals are in the ground when they react to the heat in the magma they form. Minerals are in magma, and you can find it and see it when it cools and hardens. Especially when we have igneous rocks from magma, you can see all the different minerals inside of there. So minerals are found everywhere in nature. If a mineral deposit is big enough, geologists can get the elements out of it. This is called an ore. So an ore is a mineral deposit large enough and pure enough to be mined for profit. You wouldn't want ore to have different minerals mixed in it, otherwise you really can't use it as a product. It would need to be big enough and pure enough. Minerals can be mined in two ways. Surface mining, which is just what it sounds like, on the surface of the earth, or subsurface mining, where mine shafts and all of these things would have to be built in order to get the minerals. I know some of you might recognize the word ore from your favorite game, Minecraft. What do we use minerals for? Well, metallic minerals are good conductors. You probably have talked about conductors maybe in 5th or 4th grade in science when you were making circuits. A conductor would pass along electricity. Conductors usually don't rust and they're nice and strong. A non-metallic mineral might be good as an insulator, kind of the opposite of a conductor. These would be used in industry. And then we've got my favorite, gemstones. Gemstones are valued for their beauty and rarity. Some gemstones you might hear about are diamonds, rubies, and sapphires. So, a quick recap. Minerals must be natural, inorganic, solid, with a definite crystalline structure. And there are various ways to identify minerals. One of those being color. Then we've got streak, a mineral's luster, how it breaks with either cleavage or fracture, hardness, and density. That's all for now.